Assalamualaikum, my name is Muhammad Faiz Hakim bin Ahmad, metric number AE2000326. Now I want to share the manual calculation for the 4-hour circuit. So this is the graph and the piecewise function, which is Vt equal to 3 with 0 to 1 and 0 the limit 1 to 2. So for the time is 2 seconds, and for the frequency 1/2, which is 0.5 Hz. So for the omega naught, we can get with this formula and we get pi. For the A naught, we find it with this formula, which is 1/t integration 0 to t ft dt, and we put the value for each value and we get 3/2. So we have to find AN and BN. For AN, we use this formula, which is 2/t integrate 0 until t ft cos n omega naught t dt, and we insert the value 2/2 integrate 0 to 1 3 cos n omega naught t dt, and we get the answer, which is 0. For the BN, we use the formula which the same with AN, but we change cos to sine, and we insert the formula, which is 2/2 integrate 0 to 1 3 sine n omega naught t dt, and after we calculate, we get minus 3/n pi in bracket minus 1 power of n minus 1. And for Bn, if n even number, which is Bn equal to 0, and if n odd number, we can get n over pi, 6/n pi. Hence we can calculate the Vt, which is using this formula, A naught plus summation An cos n omega naught t plus Bn sin n omega naught t, and we calculate the value for all the value, and we get 3/2 plus 6/pi summation 1/n sin n omega t. And this is our circuit, and we transform into S domain, so we can calculate the Z, which is R is parallel with LC, and we use this formula, which is 650 millisecond plus 666.67 times with 470 divide by 650 plus 666.67 plus 470, and we get the value, which is 203,667,685 over 470 plus 6.6670.65. So we calculate the ZR, and we get this formula, this answer. Okay, next we can use the formula. We can use this formula, which is 3/2 plus 3/pi summation 1/n sin n omega dot cos n pi t plus 2/pi sin n pi t. For the Vn, we can use this formula, which is square root Van power of 2 plus Vbn power of 2, and we insert the value of Van and Vbn, and we calculate, and we get 6/n pi. For the theta n, we can use minus sign, or in bracket 6/n pi divide by 0, and we get negative 90. For n1, n3, and n5, we use this formula, and we get the answer. So for the V0, we use Z over Zt times Vt. So we insert the value of Z, and we insert the value of Zt, which is this one, and Vt. So for the V node, we insert the value of this one and we divide by this one and times V3. For n equal to 1 for the V node, we use this formula and we get the answer, which is 0.872 153.42 degree millivolt. For the N3 we get 0.097, which the degree is negative 190 degree millivolt. And for the N5 we get 0.344 with the degree minus 180 millivolt. Okay, for the current, for the N1 we get N1.86, and for the N2 we get 0.21, and for the N3 we get 0.73. So the power average for our circuit, which is we use the formula P average in bracket VDC times with IDC plus Vn times In divided by 2 cos theta V minus theta I, which is K equal to 2n minus 1. So we insert all the value and we get the answer 4.787 milliwatt. Okay, that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Munzir Hakim bin Abdul Malik. My matrix number is AE2000020. I will show you the circuit simulation for our group project, the transform circuit group project. Okay, as for this simulation, I am using the LT-Spice software. As you can see, this is the circuit that we have chosen. We are using two capacitors. One is 4.7 microfarad and the other one is 1.5 microfarad. An inductor, which is 650 millihenry, and a resistor 470 ohm. As you can see, the voltage supply we are using the square waveform voltage. This is the setting. Okay, I will run the software now. Okay, this first we will see the voltage for a voltage supply for our circuit. This is the square waveform that you can see. Okay, now we will see the voltage for a resistor here. Okay, we'll look at the FFT. Okay, as you can see, now this is our FFT, our Fourier analysis for this circuit. The voltage at the resistor, as you can see, it is at about 9.5 millivolt. Okay, here is our graph for Fourier analysis. Okay, and then now we will see the current for the voltage, current for the resistor here. Okay, now you can see the graph for the FFT for the current. So this is our Fourier analysis for current for this circuit. I think that is all from me. Thank you.